Alright, welcome back everyone. If you haven't watched part one of the this Techniques turntable repair, I'll put the link down below. So here we are in the second part. I've come up with a bit of a plan. So what I think I'm going to do is I am going to remove the driver IC for sure, and then that'll allow us to test voltages at various points on the board. But to make it easier, what I'm also going to do is first of all remove these zip ties, and that'll free the board to a certain extent, not a whole lot, but that'll free the board from here. And I've actually already removed these up here, but I'm going to also pull out the voltage regulator, and for the time being I'm going to mount it onto an external heatsink. So what I'm going to do is I'm going to unwrap these wires, which are just wrapped up on those pins right there, and those are the AC lines coming into the board for power directly from the transformer. And I'm going to use some alligator clips from here. I'm going to be able to set this board on the workbench and flip it over so I can have an easier time working on it. And that'll make it less of a hassle, and I also avoid having it on this big metallic surface, which I won't have to worry so much about shorting anything out. And since I'll only be manipulating this, it'll make everything a lot easier. So we're gonna do that, and it'll take a couple minutes here, so let's go ahead and do that. Alright, so now the board's out, and I got a couple alligator clips here that I'm going to be using. I got the transistor mounted on the heatsink, and the biggest reason why I just want it on the heatsink is because it is being used as a linear regulator, so it's going to produce a little bit of heat, and I would just rather be safe and avoid damaging another part, you know, adding more to what we already have to deal with here. And I don't know if this is still done very much. I haven't seen it very much in more recent products, but maybe some of the younger people watching this video might not know, is a lot of these wires used to be wrapped around these little pegs like this, and it was I mean, I encountered it mostly on like a lot of older stereo equipment. What I've done is I've just kind of like recoiled it a little bit just so it's not sticking out so long, because they're about like that long fully unwrapped, so that makes it a little bit more compact, and then that way I can get the alligator clips over them like that, and I don't have to worry too much about them shorting out together. Even though this one is a low voltage out of the transformer, I think it's only putting out like close to 30 volts or so, but I still don't want it to be shorting out against a bunch of other crap, so that will help out. And then that way I can just, whenever I want to go to test it, I can just plug in these alligator clips in like that, and those can just kind of sit there, not move around so much. I can turn the switch on. It's not plugged in right now, but you know, that way I can just quickly turn it on to test. And I still need to suck this out of here, and after that we'll be ready to go. So it'll make it so much easier, because then I can just flip this over. It'd probably be a lot easier if I positioned it this way, so that way the two wires up there aren't interfering with anything. They will just sit there clipped on happily, and I can poke around, check voltages, and make sure that everything seems to be okay, or make sure that things are working somewhat okay before I go and put the main controller back in and the motor driver back in. One thing that's kind of handy that I noticed on the schematic is that there's only like 4 control lines going from the main controller to the motor driver. There's these 2 right here, which run down to here, and there's 2 pins on the motor driver there. One says ECR, the other one says EC, and then there's 2 more up here. These 2, actually one of these doesn't look like it goes to the motor driver, it just goes up to this point marked FG, which I believe is this kind of a square patterned foil on the sides of the where the main armature is. And I guess that just detects the position of the magnet. But then there's this other line, the one underneath that, which goes across here, goes to this cap, and then drops down. And that's another point here called there's another point marked PC. So yeah, so I guess it's only 3 lines then that actually control the motor driver. And you can see all the other stuff over there, the position detection coil, the armature coil, and we also have some pretty nice little diagrams here with the waveforms that we should be expecting at certain points, like that right there. That looks like a little sine wave. And there's another one there. There's a few other interesting ones over here that we're gonna have to look at once we actually install this chip back on. There's one that's supposed to be that 4.13 megahertz at the oscillator pin of the control chip, and there's some square action going on there for start and stop. Let's see what else we got here. We got some more square waves right there. There's a triangle wave over here on this one, and this is another chip right here that we're gonna have to check too. This one that says pitch control. So yeah, other fun stuff to check once we actually get to it. But the first thing we need to do is check all the voltages and make sure that they're actually getting what the ICs are getting what they're supposed to be getting. We got to make sure that we've got this 10 volts down here. And once we do all that, then we'll move on to the rest. First things first, let's remove this driver. Well, that was nice and easy. Not all in one piece. Whoops. So, nice. We'll set that aside. So now we're ready to start checking voltages. I went and I cleaned the contacts that I just, from the chip that I just removed with some copper braid, and then I cleaned them all up with some alcohol so everything's nice and clean. It's not all sticky. I've got the alligator clips hooked up over here on the side in a way that they're not gonna short if they shift a little bit. Kind of ran them back around. I decided to flip this over and not keep it the other way around because everything here is easier to read since it's not upside down. And then I got the wires running up there behind the multimeter going to the transformer leads. And all I need to do now is plug it in and turn it on. So let's find the plug here. Alright, it's plugged in. And the first thing we're going to check is the input voltage, which I'm already pretty sure it says fine. According to the schematic, we're supposed to be getting about 35.8 volts at this point right here, which is the... Actually, I need to set this to the right thing first of all. So, okay, we're on volts now. And at this point right here on C1, we should be getting those 35.8 volts because that's straight out of the rectifier, which is right here, and that's the positive. So let's turn it on and see what we're getting. Here goes on. Nothing hissing, nothing smoking. Okay, so let's tap into there, and holy crap, we're getting 41.25, which is fine. It's unregulated voltage coming in, so that seems like it should be okay. And then let's check the emitter from Q1, which is the main regulator up here. According to the schematic, we should be getting 21 volts out of that. So that would be J3, which is this point right here, the farthest to the left. So we are getting 20.434. Again, it's off by just a little bit, so not going to worry too much about it. It's close enough. So okay, so that's working. Let's see what else we can check. At pin 19 and 20 of the driver IC, we should be getting 21 volts as well. So let's see, we got 13, 14, 15, 16, 17, 18, 19, 20, and 21. So yeah, 19 and 20. So these two right here should be 20. Okay, so that's the voltage coming out of the regulator, so that's good. And we should be, okay, we're not going to be getting anything at the power pin of the control IC because we don't have that transistor as a regulator there. But on the, let's see which one, on the collector, we should be getting the 21 volt or the 20.4 that we're getting here. So we've got, it's actually marked on the board here, which is nice. We got emitter, collector, and base. So at the center pin here, there should be 20 volts, and there is. At the base, it says we should be getting about 10 volts, but I don't think we're going to be getting that here because not everything's in place. So 20 volts. Yeah, because there's a resistor that's going from the 21 volt line to the base of this transistor. So that actually seems like it's about right for now, since there's no regulation going on. So it appears that the voltages that are supposed to go to most of the components is fine, because everything feeds off of that 21 volts, and that all seems like it's okay. So the regulator portion is working just fine. So what I'm going to do now is I'm going to have to find a transistor for this. I'll probably cut this video off here soon. It might be getting a little bit long now. And yeah, so I'll find a transistor for this regulator. And after that we'll continue, and we'll see what other things we need to start looking for once we've got that 10 volts here. Although it looks like that 10 volts only feeds the control IC here. And actually it looks like there's 2 volts that we should be getting from there. It looks like we should be getting a 10 volt and a 9.4 at the emitter. Yeah, and right now there's nothing at this emitter, so it most likely it requires that this transistor to be in place. Alright, so yeah, I'll look for a transistor that can replace this, and then we'll continue. And we'll see what else we might find, or hopefully maybe that's the only issue now. I don't know, because I've already checked. Well, like I said, this transistor up here is only for driving the LEDs on the strobe. So that one there, we should be able to just leave that in place. I've already checked this transistor here, and that one is appears to be okay. There's 3 transistors over here. I mean 2 transistors, Q3 and Q2, but those are actually part of the regulator circuit, so obviously those are working fine. So nothing doing there. And the 40 series logic up here, that one is also fed by the 21 volts, so that one should be getting its the power it needs. Actually, now that I look at it, there's actually a Zener that's hooked up in line with the 21 volts, so it drops it down to 5.6. so at pin 14 over here we should be getting 5.6, or at least we hope. Let's check and see what we got. 5.27, close enough. That should be okay, not going to worry about that. And the IC for the pitch control, which is this one right here, the single inline package, that one's also fed off of the 9.4 volts, which is part of this transistor down here. So not going to be able to check that until we get this transistor in place. So I've got to get this transistor now, and then we can go ahead and continue. So again, thanks for watching. Hopefully I'll be able to find something soon, and then we'll continue with these videos. So thanks, and I'll see you guys next time.